at NASA Goddard's Space Flight Center in Greenbelt, Maryland. We're going to be discussing wildfires for about the next hour. We're taking your questions at the hashtag NASAFire, or also using the hashtag AskNASA. You can also type your questions into the YouTube comments box or here on the Google Plus page. Joining us for this wildfire hangout are a number of experts. Here at NASA Goddard, in a different building than where I am, is Doug Morton. He is a research scientist here at NASA Goddard and a fire specialist. Joining us from NASA's Jet Propulsion Laboratory out in California is Bill Patzert. He's a climatologist. And then also joining us from the U.S. Forest Service is Elizabeth Reinhardt. She's the Assistant Director for Fire and Aviation Management there at the Forest Service. We know we have a number of viewers today. This is also going to be archived on YouTube, but as we're doing it right now, please submit your questions, send them in. We have a body of people here getting them and pulling them in, and I'll be reading them on the air. Just to kick things off right away, I want to go right to Bill Patzert out there at NASA's JPL lab to talk about what essentially it takes to start a wildfire. Take it away, Bill.
Well, good morning, everybody. The first thing to understand is that fire is a very natural part of our ecosystems, and here in the American West, our history has been written in great fires. But the nature of fires and their behavior has changed over the past few decades. Fire seasons are longer. The number of acres of fire, of wildland that is burned has increased dramatically. Costs are up. Fatalities are up. And there's more and more costs for things like aviation. Now, just to start at the 101 level, at the simplest level, fire equals fuel plus ignition. It's a pretty simple formula. But that formula can be changed by lots of things. For instance, fires create their own meteorology, their own winds, and accompanied by driving forceful winds like here in Southern California, fires really become unmanageable and you really can't fight them. All right? And the other issue is that we fight a lot of fires in the United States. And some people think we fight too many fires. And so what happens, it becomes these great national forests naturally burn every 20 to 30 years. But when you fight too many fires, you get too much old growth forest. And it becomes a problem in itself. So you set yourself up for super fires. And then another factor is that people have moved into the wildlands in the United States. And so there are more people living in harm's way. And, you know, my simple formula is if you put people in a wildland or grasslands, that guarantees fire. And, of course, the thing we'd like to talk about here is what's the impact of climate change? We're living in a warmer world. In the West, it's a drier world. The population center of the country has switched from the Midwest and the Northeast into the West. And so we've seen more fires, larger fires, and more deadly fires. And so that sort of sets the background. And of course, NASA is trying to study all these factors, the things that set you up for a fire, how fires behave, and what the future of fires are for the West.
Elizabeth, I'd love to see if you could chime in here. You're at the U.S. Forest Service, and that seems to be part of the story we're telling about wildfires now, is the idea that there's been so much fire suppression for so many years.
I wonder if you could bring up my slide that shows the trend of acres burned over time, so that I could talk to that a little bit. You know, Bill's formula that he showed, I certainly agree with it, and we have another simple formula we talk about a lot in the Forest Service. Not that visual, but it was a bar chart showing acres burned, if you can find that. We have another simple formula we talk about in the Forest Service a lot, and that's the fire behavior triangle. And the three factors that really control fire behavior are topography, weather, and fuels. So in a given landscape, topography is a constant. and weather, we have strong indications, is currently very conducive to active fire behavior. So that leaves the one angle of the fire behavior triangle that we can possibly impact, which is fuels and vegetation. It's certainly true that fuels accumulate in the absence of disturbance. Most of our wildlands in the United States, 94% of them, fire plays a fundamental ecological role. And when that role is interrupted or removed, it has consequences. It's difficult to know to what extent the current increases in fire we're seeing are climate-driven or fuel-driven. Certainly we know that post-World War II there was a dramatic reduction in acres burned around the West. That reduction was partially due to our increased capability to suppress fires. It was partially due also to the fact that those happened to be relatively cool, wet decades. So since actually 25 years ago, I think of as sort of the point of inflection in our fire occurrence curve when we started seeing much more acreage burned, and that increase has increased over time. Some of that may be due to the fact that we entered that period in a fire deficit, so to speak. Some of the areas hadn't been visited by fire as often as maybe they were historically adapted to, so fuels had accumulated. Whether that's because we were so successful at suppressing them or because those happened to be cool, wet decades, it's a little bit hard to say, and in retrospect, well, we can only go forward from here, and our tools for going forward are to manage that vegetation in a way that sometimes includes using fire to play its natural ecological role.
I want to bring Doug Morton into the conversation and also describe where I am right now. Doug, let me throw it right to you. Over Doug's shoulder, you can see almost a visualization of fires. Doug, can you sort of explain what these visualizations show when it comes to fires?
Sure. At NASA, we have about 14 different satellites that are observing the Earth, and many of those fires are very useful for identifying actively burning fires, mapping out the burn scars that come from those fires, and of course studying how the smoke and the greenhouse gases that get released from fires contribute to global warming and also are altering other components of the Earth system. Behind me you can see an animation showing some of the active fires. This is one of the hallmarks of the way in which NASA satellites provide information, obviously to resource management groups, including the Forest Service, but also to other protected area and park managers around the world. These actively burning fires can be transmitted within 30 minutes of a satellite overpass by text message or on a smartphone to park managers around the world, including in Australia or South Africa. It's one of the vital roles that NASA data play for looking at fire and fire management. Certainly as a scientist, I'm interested in using more than just today's actively burning fires, but also looking at how those fires have changed, those trends have changed over time, to understand how the combination of factors that Bill and Elizabeth have pointed out before, the combined influence of human activity and climate change as the way that fires are playing out in the landscape.
Thanks, Doug. I want to remind everybody, and we're getting some great questions in now. I'll be reading them in just a second. You can ask questions either in the YouTube comments box or by using the hashtag NASAFires or NASAFire, or also Ask NASA. We're keeping an eye on all of them. I also want to point out where I'm situated here at NASA Goddard is one of the places where the satellite data comes in that Doug was talking about. I'm going to angle my screen back. Here you can see a satellite pass going over essentially Greenland, and there's what the satellite passes look like. This is where the data comes in from many of the Earth science satellites that NASA has: Terra, Aqua, Landsat, and that information comes in here and then is turned into what essentially are called level 1 products that scientists like Doug Morton and I believe Bill Patzert use in their computer models. Bill, I wanted to ask you, when it comes to forecasting fires in the future, how reliable are the models and how confident can the people who get ideas of what wildfires may or may not be in individual states or counties, how confident can they be about different fire forecasts?
Well, you know, remember, we have great natural cycles in the climate system. And for instance, for the last dozen years, the West has been extremely dry. Here in Southern California, since January, essentially the rain's just turned off. So we've had a very busy, active fire season. And so a good forecast of fires is drought. And as we look into the future of the West, is one of the climate forecasts is for not only a warmer West, but a drier West. And so that definitely translates into a more fiery West. And as population shifts and more people are moving into harm's way of these fires, it becomes a serious problem.
And Doug, you said you may have something to add when it comes also about developing these projections?
I think at NASA we're looking, excuse me, Bill, I was just going to chime in with a follow-on to the points you were making, which is that we're certainly interested in looking out over the next century, in particular using the latest generation of climate models to understand how conditions that do favor fire activity, those hot and dry conditions Bill was mentioning, are likely to play out. And certainly as we look out towards the end of this century, we're seeing years, for example, like 2012, which was very dry across the Front Range of the Rockies and the Midwest of the country, that kind of a fire season being the new normal by the end of the century. So certainly a trend towards hotter and drier conditions in regions that are already experiencing fires, and even an increase in those fires in places where fires haven't historically been all that important, places like the upper Midwest of the US or other northern Great Plains regions. NASA scientists are also using satellite data to understand how we can project fire on a much shorter time scale. Many of the viewers may be familiar with the influence of cycles like El Nino and how that can contribute to rainier or drier conditions in different parts of the world. We're certainly using information like that, information that comes from sea surface temperatures like the El Nino phenomenon, as well as variability in the Atlantic sea surface temperatures, to try to make projections of fire activity out just a few months. So for example, I'm a part of a research group that's made a projection of fire activity in the Amazon. We made that projection in May, and the peak of the fire season is yet to come. So those are the ways in which these tools are providing a lens on future fire activity over the scale of months to decades.
And Elizabeth, there at the Forest Service, how do you take these projections that come from the research scientists and apply them into essentially the real world when it comes to managing our nation's forests?
You know, our preparedness is the pre-positioning of fire crews and resources takes these predictions into account. We have our own predictive services groups that looks at weather projections seasonally. In addition to weather and drought, prevalence of fine fuels is an important predictor of fire behavior. So in some places where fine fuels are limiting, a wet spring actually is conducive to fire activity later in the season when those fine fuels, the grasses, begin to dry out. So we definitely take that information into account in placement and preparedness of our firefighting resources.
That actually leads us to the first question we're going to take from the internet. And just to remind anybody watching, just write questions in the YouTube comments page, in the Google Plus page here, and also we're monitoring Twitter and Facebook. She's a hashtag NASA Fire on Twitter, and we'll find it quickly. But what Elizabeth just said about a cooler spring, we got a question in Google Plus by Nicolo Lupudi. He had the question, essentially, a summer that starts barely at the end of July seems not so global warming. Explain to me why, if I have to wear a sweater in July, that actually global warming is happening and that it's actually increasing fires. I'm going to throw that, not to put you on the spot, but we've got a climatologist right here. So Bill, can you sort of draw on that idea of that if it's that cold and rainy all the way into July, how can it possibly lead to or show that climate change and global warming is happening?
Okay, that's a great question, because it's actually been pretty cool here in LA too, which we appreciate. But don't confuse weather with climate. Climate are long-term trends. And for instance, 2012 was the warmest year in the contiguous United States since modern record keeping has begun. All right, so you're definitely living in a warmer world, even though you might be having a cooler July. And the other factors, like rising sea level, which is the unequivocal proof of global warming, continues to increase. So, you know, weather can give you a break, but in the long run, climate's going to get you.
Thanks so much, Bill. Sorry to be laughing about it. It's such a serious topic, but when it comes to climate change, it's so interesting to continue to come up with the difference between individual weather and climate. And because we talk about forecasts in both, it can be a bit confusing for a lot of people. I have a question probably for Elizabeth. And people keep the questions coming in. We have a question from the YouTube comment section. Douglas Crandall asks, what's the most common ignition of wildfires? I know that sometimes we hear about arson, sometimes we hear about lightning. Can you talk a little bit, Elizabeth, what causes these wildfires, and is there a way to sort of limit one or the other?
Oh, Doug, good question. And I don't know off the top of my head what % of our fires are human-caused versus lightning-caused, but I believe the majority of them are human-caused. And we always take suppression action on human-caused wildfires. Certain parts of the country are impacted more by lightning-caused fires, and one thing we're really curious to observe as climate change plays out is what will be the impacts of climate change on prevalence of lightning and where. You know, that's the type of detail that you think. We know things are warming. We know that in a warmer climate, regardless of the precipitation patterns, vegetation is under more moisture stress, and so it's more likely to be dead and dying and dry and flammable. But some details like, where will we experience more lightning storms? Wow, that is really one of those cases where the devil's in the details, and I don't know what projections tell us about lightning-caused ignitions. In a wildland that's increasingly populated, we can only expect that human-caused ignitions will continue to increase.
And Doug,
This is Bill.
Oh, go ahead, Bill.
In California, 95% of all fires are human ignited. All right? And so my simple formula for fire in California is people equal fire.
Sorry for the pause in me. I wasn't expecting such a simple formula, Paul. Doug, can you comment a little bit too? That's an interesting idea on a possible connection between climate change, increasing intensity of storms, possibly leading to more lightning, which may cause actually more wildfires.
Well, it's fully a coupled system, and I think both Bill and Elizabeth have pointed to the important role that humans play in modifying the fire regime of our planet. Across the U.S., it might even be as much as 70% of the fires from NASA satellites are associated with fires for forest management or for agricultural production. Across places like the Brazilian Amazon, or maybe even broadly looking at California, that number is darn close to 100%. So clearly humans are an important source of ignitions. How human activities change and respond to a changing climate ultimately will influence how fires will respond as well. Those hot and dry conditions, those extreme events that I think are so critical when we think specifically about fires. Certainly there's a wide range of science and study right now on the intensity of storms, the prevalence of hurricanes, etc. But if we think just about those conditions that favor fires, those extreme events, things we consider now to be a once-a-decade kind of activity, those are certainly on the rise, whether we look at major fire regions in the western U.S., whether we look at places like Australia or southern Africa. These are places that will see more extreme fire conditions. Again, an early start to the fire year in California, a very early start to the fire year in Alaska this year.
Thanks so much, Doug Morton. Just to remind everybody watching, this is a Google Plus Hangout hosted here at NASA Goddard. It's live on YouTube now, and it will be archived on YouTube. So if you're watching after the fact, thank you so much. We're taking questions in live now through the hashtag AskNASA, through the hashtag NASAFire, and also on YouTube and here in the Google Plus page. Here's a question we have from the YouTube comments page, and this might put Elizabeth a bit on the spot, so apologies, Elizabeth. But Jack Ring on the YouTube comments section asked about, when it comes to fuel for fires, is there a difference between acreage burned in U.S. Forest Service land versus reservation land? He says, at least here in Arizona, the Native American lands are much better cleared of underbrush than are the U.S. Forest Service lands. I don't want to put you on a spot about a particular tract of land out there, but it does lead to the idea of how to manage forests as a way of minimizing wildfire risk.
Certainly, many tribes have a strong tradition of active forest management, and certainly many of our national forests are in need of fuel management treatments. However, it's also true that many of our most devastating wildfires this year have been on private lands, not federal lands of any kind. So definitely we take seriously our responsibility to manage and steward the national forests, which are a public resource and which we value deeply ourselves. So I guess I don't have any statistics for you about relative fuel conditions on tribal lands versus national forest lands, and I would certainly expect it to vary geographically. But there's no question that there's work to be done.
Thank you so much, Elizabeth. We have a question coming in through a phone bridge from a reporter from The Futurist. Hold on one moment. All right, hold on one moment. And go ahead with your question.
All right. Yeah, I heard Doug Morton say that places like the upper Midwest could see more fire activity, where those are places that have not historically seen a lot of fires. Now, I'm wondering, not too far from the upper Midwest is Canada. So could much of this fire activity become a transnational issue? For example, you could see more fires crossing to or from Canada and or the U.S., since many of those forests intersect. And if so, could this end up being a problem that Canada and the United States would have to cooperatively work together to address?
That's a really good question, and certainly we see areas like that northern forest boundary between the U.S. and Canada as some of those areas that are projected to dry the most during the fire season, based on this latest generation of climate models from the IPCC, the Intergovernmental Panel on Climate Change. The transboundary issue that you bring up is pretty important. Certainly we think directly about how these fires, forest in particular along that boundary, may be vulnerable to fire, but the long-distance transport of the smoke, aerosols that come from those fires, is something we can already point to as being a pretty significant impact. There were fires in Quebec in 2003. The smoke plume from those fires reached all the way down to where we are here in Maryland and Washington, D.C. When that smoke hit the metro area of D.C., there were thousands of 911 calls within a half an hour because people smelled smoke. That's just one example. I think if you think also about the way that we as scientists connect the aerosols, the smoke that's transported from these fires, and its transport up from the U.S. over Canada and up into the ice sheets in regions like Greenland, those aerosols and the black carbon that rains out on the ice sheets in Greenland has a significant impact on how quickly that ice is melting and how rapidly this link between fires and melting ice helps play a role in the global Earth system picture.
And Doug, I have a question. When you say black carbon, are we actually just talking about like literally soot from these fires, or is it something else more specific?
Well, fires release a range of different particle emissions. That's essentially little particles of burned vegetation. That's the black carbon piece. It's essentially like very fine charcoal. But you also see the release of carbon dioxide and methane, which are two very important greenhouse gases. And so part of the research that we do is to take information about the amount of fuels that are there in a forest as it burns. We can see some of that damage as we take NASA imagery of the burn scar after the fire passes. And we can also take measurements of the smoke plume and the greenhouse gases in the atmosphere with other NASA satellites. We can put those two pieces together in a model to understand how fires overall are contributing to the problem of global warming.
Thanks for clearing that up for me. Elizabeth Reinhardt with the U.S. Forest Service. I was wondering if you could comment a little bit about the idea of fires crossing borders. I mean, of course, fires don't actually care what side of a fence they're on. And how does the U.S. Forest Service work with Canada when it comes to fires that might be along the border?
You know, we work closely with our Canadian neighbors, and we also have agreements with other countries as well. We work with Mexico, and we have sent aid and received aid from Australia and I believe some countries in Europe in times of need. But you know what's really interesting, I think, is to address that at a much smaller scale and think about how we work across boundaries that are just property boundaries rather than national boundaries. So one thing we've been working on in the Forest Service is trying to make more of an effort to strategically locate our fuels and vegetation work in places where there's a neighboring effort right across the property line, so to speak, so that we can be good neighbors, and so that the effects of our work are, I guess, enhanced by the effects of the neighboring work. So I think there's a real opportunity for us moving forward to coordinate our work with neighboring landowners.
Thank you so much. Just so anyone tuning in now, that was Elizabeth Reinhardt. She's with the U.S. Forest Service. Also joining us.
Just add something
Oh,
here.
yeah, I was that, and joining us also is Bill Patzert at JPL. Bill, take it away.
Yeah, I just wanted to point out to everybody that fires are not only in the West. Some of the largest fires we've seen in the United States have actually occurred in the Midwest and the Northeast historically. And the other point I would make is that in a world where the climate is changing, precipitation patterns, temperature patterns, ecosystems will change. And so what a forest looks like today is not necessarily what it will look like in a half a century. And we're already beginning to see this. The great conifer forests in Canada are moving farther north. As the Arctic tundra melts, we're seeing more and more new species develop in the Arctic tundra. And even here in the United States, the level, the altitude at which various plants and trees grow is dramatically changing in some areas. And so with changing ecosystems, it will be an entirely new story with regards to fires.
So I think that's a really good and sobering point that you make, Bill. And one thing that's of concern to us is that not only is fire occurrence increasing in terms of acreage burned, but that we receive many anecdotal accounts of fire severity and intensity outside the range of people's experience, which really adds to the potential risk to firefighters, to the public, and to ecological systems if they're being stressed with a kind of disturbance that's outside the range of the historic norm.
Thank you. For anyone joining us, I'm Aries Keck here at NASA Goddard Space Flight Center, and as you can see behind me, this is where some of the data comes in from our NASA satellites. And joining us are a panel of experts. We're also taking questions on Twitter at the hashtag AskNASA or the hashtag NASAFire. Also in the YouTube comment section and here on the Google Plus page. We have a question here from Twitter. It's from @Katie Campbell. She's a multimedia journalist at KCTS9 out in Seattle. And she asked, is there any mapping or tracking of smoke or air quality decline related to wildfires? I'm going to throw that to Doug Morton first because I know he's standing essentially sitting in front of a wall of computer models. But I believe Katie Campbell's question is more about ground level pollution and not necessarily the kind of pollution that you study, Doug, or do you study both?
Well, the pollution that we see that comes from fires impacts us here in the air we breathe in the lower boundary layer, but obviously also at times can get transported around the entire globe. And so yes, I'm sitting in front of an image showing fires from the last 10 days, and you can see the extent of fires, especially in southern Africa. Those are low-intensity savanna fires. These are regions that burn every year. Yes, one of the important things that we do track, and where NASA satellite data are provided not just to NASA scientists but also to the Naval Research Lab, it's looking at operational meteorology and navigation, as well as the fact that we're following the transport of large and potentially interesting and / dangerous plumes of both dust and smoke that come from fires in Africa and transit the Atlantic and influence the Amazon region, as well as fires and industrial pollution that crosses the Pacific Ocean from areas of Southeast Asia. Just recently there have been two important examples, one with fires in Sumatra inundating areas of Singapore with the kinds of dense smoke and dangerous levels of particulate matter and surface level ozone in terms of public health impacts, the kinds of things that haven't been seen since the late 1990s and a very large El Nino event in 1997, 1998. So that juxtaposition of having large cities in regions where wildfires, especially wildfires that can generate quite a bit of smoke, really drives home this issue of how fires are impacting people in the local scale, and that those same aerosols can be transported globally, impacting regions much further away.
Excellent. We have another question coming in from YouTube. It's Jack Ring again. And that question is, have the models used to project the next few decades of wildfires been used to look backwards over the last 50 years to actually see if they predicted the reality? I'm going to throw that question first to Doug, but then I imagine that Bill and Elizabeth may have something to say about that as well. I think it also sums up on just how do you check that your forecasts and your models are actually going to show what's going to happen.
Well, we talked today about how fire in some ways is a simple equation, and in other ways fire is a complex equation. I mean, some place right now is burning, and that's true this year like every other year. It's one of the reasons why it's so valuable to have a fleet of satellites that are observing fires around the globe. That said, there are certainly conditions and things which we feel are much more predictable. If you get Santa Ana winds in Southern California, you're very likely to have fires. And again, if we look at our regions and across the globe, areas that are projected to get hotter and drier are certainly areas where the conditions are set. The climate piece of the fire triangle that Elizabeth talked about, or the fire equation that Bill mentioned, that's almost out of the picture. Now, if you imagine that humans and their role in igniting these fires are also increasing in some of these fire-prone areas, you certainly think that there's a pretty strong set of indicators that we're headed for a world with more fire. How do we check that information? Again, one of the unique things about having this long history of NASA satellite data is that we can actually go back and compare this year to previous years and how much fire we've seen in any one specific part of the globe. I mentioned some of the work we do in the Brazilian Amazon, and that is a case where we make a projection of how much fire activity we expect to see based on how the climate system has set up. Which regions are drier today than they are normally, and so those areas are primed for more fire in places where fuels, the kinds of things that we talk a lot about in the western U.S., but is important in all regions for fires. Fuels are not limiting in a tropical rainforest. You just need conditions that are dry enough to let those fires burn. So we can actually go back and check. So our projections from last year for the previous year were for a below average fire year, and it turns out that the fires we observed with NASA satellites told that same story. This is a year where we've projected actually a much higher fire year for the Brazilian Amazon and parts of the Bolivian Amazon, and we'll wait and see. I mean, certainly that's the kind of information we're sharing broadly with people as we expect this region to be at higher risk of fires. And then the NASA satellite data will tell the story about how this year actually plays out.
Thanks so much, Doug. Continue to bring the questions in. We have quite a few coming in. This one is from the comment section of YouTube, and I'm going to throw it to Bill Patzer, our climatologist there at NASA's JPL lab out in California. Iron 69 asks, is elevated CO2 going to increase the rate of plant growth significantly? And then I imagine that could have an effect on wildfires. Bill, is increased CO2 going to actually change plant growth around the world?
Well, that's an excellent question. I just read a really good paper about when you look at the growth of CO2, it has a very strong annual signal where there's, in the northern hemisphere, there's a tremendous amount of uptake of CO2, and in the northern hemisphere winter, just the opposite. There's CO2 that's gas to the atmosphere. So they characterize it, that rise and dip is becoming larger. In other words, the Earth is taking deeper breaths of CO2. All right? And so the nature of the cycle is changing. All right? But the fact is that it's slowly increasing. This year CO2 finally reached 400 parts per million. And that's almost a 40% increase in CO2 in my lifetime, which is, because I'm the oldest person here, I can say that, right? But CO2 is having a huge impact because, of course, it's making a warmer world. Most of that heat is being absorbed by the oceans, and so rising sea level, which has been 8 inches in the past century, and so the nature of all the major cycles is changing now. And ecosystem, the nature of ecosystems are changing. And so we'll have to see how this plays out.
Now, the National Cohesive Wildland Fire Strategy has apparently 3 goals: resilient landscapes, fire-adapted communities, and an effective and efficient wildfire response. Elizabeth Reinhardt there at the U.S. Forest Service, can you talk a little bit about what it would mean to have a fire-adapted community? I imagine it's more than just keeping your house particularly wet.
Right. A fire-adapted community, like a fire-resilient landscape, is one that can experience wildfire and not be devastated by it. So, you know, in the fire management community, historically, we're very, very good at putting out fires. And in fact, our initial attack success rate is like 98% or something. That means that 98% of the starts that we respond to, we just put them right out. But experience is beginning to show us that that long success rate may not be completely sustainable, that those few fires that escape, and the proportion that escapes is not seeming to grow, but what is happening is that the ones that escape are bigger than they've been in the past. We're having more big fires, and the big fires are getting bigger. That's what's causing our great increases in acres burned. So we really have to plan, not just to respond to fires, not just to put fires out, but we need to be proactive about planning for enduring fire, for being resilient in the face of fire. And in an ecological sense, that makes total sense, because we know most of our wild ecosystems evolved as fire adapted. So 94% of our wildlands, fire plays a fundamental ecological role. So if we manage those forests to be healthy, they can withstand fire and come back and continue to be healthy. But what about communities? We as people also need to learn to be fire adapted, just as ponderosa pine trees might be. And what does that involve? It involves a number of things. It involves managing the vegetation immediately around your residence. And it involves constructing homes out of less flammable materials. Little things like having closed gutters instead of gutters that are full of pine needles can make a big difference in surviving a wildfire. Another aspect of fire-adapted communities is planning communications ahead of time, and also planning so that there's access in and out of the community. A community that only has one access road going into it doesn't tend to be very well adapted to wildfire.
Thank you so much, Elizabeth. For anyone
Ariel,
joining,
I could add something to that, please.
go right ahead. Let me just remind everyone, please keep the questions coming in, both on YouTube and on Twitter. And we'll be we're following along on hashtag NASAFire. And I'm going to pass it right off to Bill Patzert there at NASA's JPL lab. He's our climatologist joining us today. Go ahead, Bill.
Well, there's a growing tendency in the American West for more and more urban and suburban development, not only near wildlands, but into wildlands. All right, and this is what I call high-risk zoning. All right, people that like to build their communities in things that look like national forests. All right, and that's a dangerous business, because all these lands were made to burn every 20 to 30 years. Now, you can protect yourself by having more stringent construction standards. In other words, you can build to protect yourself against fire. And in many communities, those standards are not zoned, they're not legalized, and so they're at high risk. The other thing is, in California, you're required to build defensible areas if you live near grasslands and wildlands, and that's another thing that's not enforced. And so the consequence of this is that there is just too much expensive firefighting going on in the American West, defending homes that 30 years ago this was wildland. Now it's expensive communities that 30 years ago were not allowed to exist in these wild areas, and so you know, this is it's dangerous, it's deadly, and it's costly.
Thank you so much, Bill. Just from people dialing now, I'm Aries Keck here at NASA Goddard Space Flight Center, and we're joined by Bill Patzert out at NASA's JPL lab. He's a climatologist. Doug Morton, also here at NASA Goddard, and Elizabeth Reinhardt, who's with the U.S. Forest Service. we have a question coming in, and I'd like to sort of throw this to Doug. That question is, could you comment a little bit, Doug, on the use of NDVI, for anyone listening, that is a measure of vegetation, and then also soil moisture to assess drought impacts and pine beetle infestations. Doug, I'm going to ask you to back out a little bit from going right into those two particular fields of data and pine beetles, and just talk a little bit about how NASA has been, for decades, has been studying fire using satellites, and then go more specific about how possibly effects like pine beetles and soil moisture can be measured from space and then used in these wildfires.
Take a deep breath. That's a lot to think about. But it's true that we do use our satellites to study the health and productivity of vegetation. That's in part what you understand from the idea of you can see green vegetation, you can see brown or dried out vegetation, in the way that we use our satellites from space. That helps us understand quite a bit about the vulnerability of some of these forested landscapes, in particular to fire. NDVI is just one measure of how much green vegetation we have, and that's a measurement we've been making for decades now, since the launch of the earliest satellites in the early 1970s. So we have an idea about how our planet's changing, which areas are responding to the variability we see in climate by growing more vegetation, or in areas like the driest parts of the Mountain West, areas where those same beetles are killing large areas of forest, making that tinder dry region that much more vulnerable to fires. We have a couple of new satellites that we've been using now for only the last decade to look at how water is stored in the landscape. I will point anyone who's interested to learn more from the GRACE satellites, a really amazing set of tools that allow us to look at how water that's stored in the ground is changing season to season, year to year. So for very large river basins like the Mississippi or the Amazon, we can actually see whether this is a drought year or a flood year just by changes in gravity, since that water and the flow of water in those systems is very heavy, and things like mountains, although they influence the Earth's gravity, are pretty fixed. So we can put those different pieces of the puzzle together, again, using NASA satellites to study rainfall, to look at how that rainfall, the memory of that rainfall in the lands, through the measure of soil moisture, and then how the vegetation on those landscapes is responding. Each of those pieces comes together to help us understand the risks of fire. For people living in the Mountain West, beetles are a reality. I think that comes back again to a point that Bill made earlier, thinking about how climate change on our warmer world is altering a wide range of systems. Warmer winters allow beetles to overwinter and then kill more trees, and those dead trees are then primed for large wildfires in those mountain areas.
Now, we have a question coming in from Twitter. It is wondering, what is possibly the biggest misconception that you as scientists have heard about the connection between wildfires and climate change? I'm going to throw it to our climatologist, either Bill first, but I'd love to hear what Elizabeth has to say, and Doug has to say about that too. We're talking about misconceptions here when it comes to the connection between climate change and wildfires. Bill?
Well, you know, climate change is definitely the real deal. We're living in a warmer world, and climate patterns all over the planet are subtly changing. But every time you see a fire, or you see a hurricane or a tornado, and you turn on the evening news and they tell you you're living in a wilder world because of climate change, that's not entirely true. Because the other thing that happens is that there are more and more of us living in harm's way. Anybody that lives within 18 inches of sea level on the American Gulf Coast or the East Coast, all right, is definitely asking for it. Or if you live outside Oklahoma City without a storm shelter, or in the American West, if you build in wild areas that historically burned every 20 to 30 years. And so a big part of this is just tremendous growth in population density, and people moving into areas that historically have flooded and burned. You know, in Southern California in 1950, there were 4 million people. Now there are more than 20 million people between San Diego and Santa Barbara, and more of them are living in harm's way. And so climate change is the real deal, but human behavior is the dominant factor.
I'm going to jump in there for a second. I know I was going to throw it to both Elizabeth and Doug, but we have a question in from YouTube that leads to this topic. Matt Haldane asked that wildfires have traditionally contributed a small amount of damage compared to other natural disasters like hurricanes and flooding. And so we've answered this a little bit, but I'd like to have Elizabeth address a little more. Are we going to see wildfires becoming sort of a greater piece of our overall damage pie happening here in the U.S. in the coming years?
Some people certainly think so. And to be clear, that the direct costs of wildfire in terms of putting out the fire are only a small piece of what wildfire costs society in terms of damaged watersheds, subsequent flooding, and damaged utilities, things like that. But it's also likely that other natural hazards may respond to climate change with an increased signal. So I don't really like to speculate, but I would like to add something to what Bill said, which is that any given fire, just like any storm, we can't really say, oh, this is a climate change caused event. It might have, we know that fire in general is episodic and highly variable. So it's the fires we see might have been seen 100 years ago or 200 years ago, any individual fire. But what I think we need to keep our eye on is trends. And when we look at fire occurrence in the West, we do see a very, very strong trend in the last 25 years that I think we can't ignore.
Doug, I'd love to throw a question to you, especially when it comes to we've been talking a lot about climate change. In the next few weeks, in the next few months, we'll hear about the IPCC report that's going to be coming out. I'd love, Doug, if you could talk a little about what is the IPCC report for people who haven't heard of it, and then do you know what it says particularly about climate change? Can you give us a bit of a preview about it?
Well, first off, I'll say that I'm not an author of this version of the IPCC report. The Intergovernmental Panel on Climate Change is an intergovernmental, a global effort of the nation's top scientists from around the world that gathers together to understand and synthesize climate research. There's also a component of that work, which is not just the synthesis, but is the fact that we as scientists are trying to generate new understanding of our climate and how the Earth is functioning as a system. That newest, latest research is also one of the things that people will look for when the IPCC releases their 5th assessment report in the first part of it in September. No, I don't have any of the major highlights to share with everybody a month in advance, but one thing I can say is that the climate models that were run to help inform that assessment report, those data are available. And so when we look out at those data, we've been seeing a visualization of the dryness of the atmosphere over North America. That's actually derived from those latest generation of climate models. Those climate models in aggregate have a very similar story that they tell about a warming and drying set of conditions across the central and northeastern portions of North America, that area of the Mountain West all the way out into Quebec. One of the things I would come back to, though, that I think is really important as we think about fire and climate change is the idea that climate influences fire in ways that we don't always anticipate. So a warmer night may not trigger the public's attention, but it certainly makes a difference for fighting a wildfire. The same is true for a warmer winter. Much of the warming we've seen across North America in the last 30 or 40 years has actually been in the wintertime. But I don't need to tell the viewers in the Mountain West, either the ones who like to ski in the winter or the ones worried about wildfire in the summer, that less snowpack from warmer winters means important things like more beetles coming through the winter, as well as bigger and more dangerous wildfires in the summertime. So I think that idea that climate and the changes in climate we see in a warmer world impacts fires in ways we don't always think about is certainly an important message to convey.
Thank you so much, Doug. For anyone tuning in, I'm Aries Keck. I'm here at NASA Goddard Space Flight Center, and we're talking about wildfires and the increased amount of them this year and also their connections to climate change. I have a question I'm going to give to Bill Patzert there at NASA's JPL Center, because I think it leads to some of the misconceptions people have about things. In YouTube comments, Mark Madrid asked, is the sun's magnetic change going to affect our weather in coming months? So Bill, I'd love to hear what you have to say as a climatologist about the effects of the sun on wildfires here on Earth. I know there's probably some people who think it could have a lot to do, nothing to do. Can you sort of clear up some misconceptions there?
Well, the sun's magnetic field switches approximately every 11 years. It's the great 11-year solar cycle. And it probably has subtle impacts on our climate and our weather, but it doesn't have major impacts. And so when we look at the great cycles, El Nino, La Nina, or even decadal scale, 10 to 20-year droughts, or long-term trends like global warming, the solar cycle, the switch in the magnetic field every 11 years, is not a major factor.
Okay, then we have a question from a reporter from Climate Wire, Nathaniel Massey. He would like to know, and I know Doug just mentioned snow a minute ago. He would like to know if we could comment a little bit about the heat wave and wildfires that are being seen in Siberia right now. Not a place you would think of having a lot of fire. Nathaniel would like to know how far out of the norm are these fires, what weather systems, possibly the jet stream, might be contributing to them, and then what might these effects and impacts do to the albedo in the region? I'm going to throw that question to Doug, and also I'd love for you could back up a little bit. Doug, can you explain first for people what is albedo, and I could repeat the question.
It's a really good set of questions around a current event. There is a heat wave right now over the northern portions of Russia and the Siberian region. That reflects what's called an atmospheric blocking event. I'll take 2 steps back from that if I can to suggest that the flow of air patterns across the northern hemisphere and their dominant patterns of that jet stream and the flow of the atmosphere is what does bring us our typical weather and what we think about as changing over time if we're looking at changes in climate change. One of the things that's sort of most striking about how changes in the Arctic, now I'm thinking about things like the melting of sea ice, influences the circulation of our atmosphere, is that we have seen in recent years several episodes where a high pressure system over the Arctic and the northern high latitudes can lead to this sort of block of hot air that sits over one region and allows these fires to burn for days and days. Those kinds of conditions, those kinds of connections are one of the reasons why we here at NASA are trying to understand the Earth as a system. It's not enough just to look at fire and not think about how the adjacent changes in the sea surface temperatures that Bill mentioned, or the melting of Arctic sea ice, which we know during the northern hemisphere summer is reaching now close to its minimum this year. All of those patterns influence how our atmosphere circulates over the Earth. The question came back to albedo, one that for scientists is a familiar phenomenon, but just really reflects, pardon the pun, how much of the sun's incoming radiation gets sent back into space. So very dark things like the open ocean or dark forests absorb more of the sun's incoming radiation than very bright surfaces. Think about fresh snow or ice. And so one of the things that both fires and changes in sea ice do is they change the albedo. They change how much energy gets absorbed in any one of these locations and then how that propagates through the Earth system. That's really why this Earth system is such a complex puzzle, and one that we are using, again, most of the satellite data we have available to us, along with these complex computer models, to try to disentangle.
Thank you so much, Doug. I'm also the next question is for Elizabeth Reinhardt at the U.S. Forest Service, and it's an interesting question. It came in through YouTube. Raven Blackheart, probably not a real name, asks, does anyone know if there's any work being done on genetically modified trees so they might be able to consume more CO2? And Elizabeth, I'd like to broaden that out a little bit. What about also genetically modifying trees so they don't catch fire as quickly?
I don't know of any work to modify trees so that they don't catch fire as quickly. There's a great deal of genetic variability in nature, and differences between species in fire resistance are really the management key here. And one of the reasons we have a fire problem is because stands that were formerly very fire resistant, ponderosa pine, have been invaded by encroaching Douglas fir that's much more fire susceptible, and so on. So I think that I don't know if we need to go so far as to look for genetically modified trees to look at genetic variability as part of an answer to our fire problem. Now, in terms of capturing more CO2, that's another really interesting question, and I don't know the answer. Forests certainly play a key role in mitigating CO2 emissions. But again, rather than looking to a genetically modified organism, I think what we really need is reforestation of currently unforested areas. It has a lot of potential to increase our carbon sequestration capacity of forests.
Thank you. Bill, I'd love to know, as a climatologist, when it comes to these kind of questions, we heard Doug talk about the Earth as an entire system. Is there a way of sort of gaming that system that you and other climatologists could look forward to keeping us possibly more resilient to climate change in the future?
Well, that was really an excellent question, and my simple answer is that you can't game Mother Nature. But as climate has changed throughout history, when we look back over the last, let's say 100 million years, ecosystems have genetically modified themselves. The composition of ecosystems change as climate changes. And so it's subtle. But as we're talking here this morning, is that ecosystems throughout the planet are actually, in subtle ways, modifying themselves. It's called evolution, all right? And so as we look into the future, we see the distribution of plants, trees, and animal species as well. They're changing in subtle ways, and they will respond to the changing climate. And so, the good old days, whatever it used to be, are gone forever. And so it'll be interesting to see, because climate change is not going to be stopping anytime soon. It's the real deal. It's in our future. And we don't know exactly where it's going, but I predict that in 200 to 300 years, the great forests as we see them today will look much differently.
Well, thank you all so much for joining us today. That was Bill Patzert. He's at NASA's JPL Jet Propulsion Lab out in Pasadena, California, which actually saw its own fire right on its doorstep, I believe, last year. Also joining us today has been Doug Morton. He's a research scientist here at NASA's Goddard Space Flight Center in Greenbelt, Maryland. And then also Elizabeth Reinhardt, who is the Assistant Director of Fire and Aviation Management at the U.S. Forest Service. She's joined us from Washington, D.C. Thank you all so much for watching. We really appreciated all your questions and calls. This is going to remain on YouTube as archived version, so if you're watching through the archived version and you have additional questions, please just continue to use the hashtag NASAFire, or send a question right to the @NASAGoddard Twitter account, or put it on our Facebook page. I'm Aries Keck here at NASA Goddard. Thank you so much all for listening.
Thank you.